كل سواد لا ماشي
Okay.
مش عشان اقوله
So this is, well, so what I propose to do today is, it says a crash course in MATLAB. Now I think I'm going to try to follow what it says, like morally, on this, but it's hard for me to have this open at the same time and sort of like make sure that I've actually done every step in the thing. So I would like to think of this little chapter as a little document that you can read and look at, and what I'm going to lecture that I'm going to do is going to be pretty similar to it. Maybe not identical, because it's hard for me to switch between the two and make sure that I've done everything exactly the same. And I'm going to sort of ignore it and just once in a while I'm going to look at it. And instead of showing you a picture of the window, I'm going to show you the actual window. And I'm going to attempt to make all the fonts bigger, so give me a second to see if I can actually manage this. Fonts. Now if I do this, what happens? Is it too late?
نزل هذه
Well,
بدل
that's
بدل
here, but this
كذب
is-
يرون نجح ونص يصير
Let's call the workspace. Let's see if we have a workspace. Okay, well, we're gonna cross our fingers. Okay, this is the MATLAB window. I don't know if it'll look exactly the same when you go to the lab, because you can also customize it. So for example, I can crack this thing out, I can undock here, and now I've got it separate, and now suddenly everything looks different, right? I can even close this. Oh no, it's gone. And now I've got this, right? And if you end up, a lot of people end up with, most of their windows are gone, or they're in some weird place and they're looking for it and they can't find it. There's a button somewhere which I'm going to look for now to try to restore the workspace to default. Now, how does it work? Find it. I think if I can't find it right now, layout, here it is, default. So now the enter window didn't reappear because this is a
ما
default
اختبرت
view.
عشان خاف منه
I also like to have my editor window, so this is my editor window, and by default you see now that I've clicked to open. Wow, oh no. Now that I've clicked to open it, you see it's kind of separate like this, but it's hard when I'm teaching, right? I've got this thing in front of the other thing, it's very confusing, so I don't like it when they're on top of each other for the teaching purpose, so I'm going to dock it. So I'm going to go here, and I'm going to dock it. You don't have to do it the same as me, but I'm going to dock it, and now it's right here. It's the same thing, but they're tiled so we can all see better. Okay? So but the essential part is if you're wondering where all your stuff is, wherever it was, there's a layout default, and that's going to put it back to something sane. Okay? And now let's talk about the panes that we were seeing here. So I've made the fonts, some of the fonts are bigger. I regret to say that some of the fonts are not, but anyways, this is bigger, right? Is this big enough that we can see? By the way, I lost my glasses because of ADHD, so I can't see you guys. I'm going to try to find my glasses, but they might be gone. I'm not even sure. Yeah, I know.
أعطيك سب
Might as well wait. My wife has the same
والله شيء
reaction.
أعطي زب
So, right, so this is the current folder. I mean, this is basically, you guys know this window, right? This thing? Hold on. This thing, the File Explorer, right? You know this, and you can click here and go see your, I'm glad I don't have anything in downloads. Pictures, okay, safe, all right. So this is the File Explorer, right? And this is kind of like a mini File Explorer that's built into MATLAB. And you can see the directory that it's in over here. And this is important because when you start working, you have to make sure that you're in a directory where you can save files. And I've seen often that when the MATLAB opens, people are in a directory where they can't save their files, or they're in a different directory than the last time they worked with it, and they can't find their files anywhere. So it's important to go and find a suitable directory. So you can click on this, and you should be familiar with a window like this, right? And then you can go and choose like music, or I don't know what, this PC, and then you can documents. You can go where you want, right? Pick a reasonable directory. By now, you guys know how to use computers. You've done all your schooling, and you've done your essays. You have to save a file somewhere on the computer. So you have to start by doing this, and you navigate to a certain folder. Maybe you create it, and eventually you end up there. In your case, there'll be nothing in the folder. In my case, there's stuff from the previous years. Okay? And that's the folder. Now, I'm going to open a random one here, this one. I don't know what's in it. Okay, so I'm going to say something about this. It says there, open this file as a live script. There's a bunch of every year MATLAB does some new things, and the latest thing is always buggy as heck. Last year there were some students who were using the latest features, and they corrupted their files many times. And I don't actually know what that feature is, because I never use it. Thankfully I was able to rescue their files, but it was a bit crazy. So I'm going to close this, and I'm not using this. So up to you if you want to use this live script. I'm not using it. Okay. So now I've got my editor window here, and you can see that I've got like a bunch of programs, and MATLAB programs. This is my program here. But as it is, nothing happens. Right? It's just sitting there. Might as well be a Word file. You're just looking at it. Okay. So if you want it to do something, you have to run it. And before I run an actual script, I'm going to run individual commands. And now I'm going to try to teach you my opinion on how programming works. I will say, I say this every year, and students like it, so I'll say it. I used to work in California. I worked for NVIDIA and Sun and Amazon, and I was not in California, but I worked for them. You might know the Xbox. The original one. I'm one of the designers of the graphics chip on the Xbox, so I know how to program really, really well. I was also did the programming Olympiads. I didn't want to stay there and continue there because of the ADHD, so that's why I was like, okay, that's enough. I'm going to teach it instead because I like that better. So that's why I'm here. So I'm a very good programmer. And maybe it's a bit hard for me to relate because I started programming when I was very small and I was very good at it. So it's not the same as learning how to program when you're an adult. But I'm going to try to understand as best as I can. So, and in my opinion, when you start programming, you need to, there's a temptation to, you've got an idea of what you want for programming, you write a gigantic, just imagine opening your text editor and you write everything, all your ideas, one after the other. And then you put it in MATLAB and you try it, and of course it doesn't work. That doesn't work. That has never worked. It's not going to work even for me, even though I was doing competitive programming. That would never work for me. So how do you actually program? So it's an iteration between the command window, which is down here, and the editor window, which is up here. So let's say that I want to do 1 plus 3. Okay? So maybe I go, maybe I go, in the olden days there was no 1 on the typewriter. My mom had a typewriter, and there was no number 1. There was like number 2, 3, 4. For the number 1, you were supposed to put an L. So I'm going to pretend that I'm my mom. So instead of putting a 1, I'm going to put an L. Okay, that's my mistake. So here, you guys see how it looks like a 1, right?
Okay.
But it's an L. And I'm going to 2 plus 3. This is my program, okay? Now imagine if you had gone and typed this right into your program already from the beginning. This is not in my program. This is in the, up there is the editor. Down there is the command window. I'm typing this in the command window. I'm telling you, you never type it into the editor. You type it in the command window. That's what my point here. Because if I hit enter, okay, undefined function or variable L. It's in red. It's an error message. I know I did something wrong. If you write your whole program in the editor without doing this, it's going to be full of mistakes. It's going to be multiple mistakes per line. When I was a kid, I had to do dictation, French. I don't know if you do this in English, but you know, the teacher reads you something, like says something, and you have to write it down, and you get mistakes, and then if you have 1 mistake, it's 9 out of 10. If you have 2 mistakes, it's 8 out of 10. If this were a dictation, and I would have a mistake there. If you write your program you're not going to have 0. You're going to have negative 100 out of. You're going to have so many mistakes. You're going to have multiple mistakes per line, right? And the only way that you're going to figure those out is if you do what I did just now. You just put the command in the command window, and it tells you immediately you've got a mistake, and then you got to fix it. So now I'm going to fix it. 1 plus 3, 4. Now that I know that it works, I can copy and paste it into my program. Okay? Now let me do another command. Let's say that I want to set the variable x to 7, for example. So do I really want to plant a mistake in that? I don't think I'm going to do it correctly. So I don't even know what mistake I could make. X equals the 7. Okay? And it replies dutifully, x equals 7. It's not red, so it's not a mistake. Sometimes, even if it's not red, it could be a mistake. So you also have to read what it says to see if it's saying what you thought it would say. If the computer is telling you something unexpected, that's also a mistake, even if it doesn't say error. So, but this time it says what I expected. It says x equals 7. I expected that. I'm happy with it. So now I know this works. I can copy and paste it. Now, I want to draw your attention to what's on the right here. This is called the workspace. And now I'm going to use my fingers, or do this, the workspace. And over here it says that x is 7 and ans, which is short for answer, is 4. And so ans, I guess, was the previous one, which was 3 plus 4. Or whatever it was, that was 4. So that was the answer of the calculation. And somehow this is not an answer. Somehow. Okay? So this is the workspace. You should think of the workspace as your scratch paper that you have when you do the exam for your calculations. That's the computer's scratch paper. And you can have multiple pieces of scratch paper when you're doing your exam, right? But the computer can also have multiple pieces of scratch paper. So there could be multiple workspaces. Right now there's just one. Okay? Right, so now I'm going to pretend that I've saved this file. I didn't, but I'm going to pretend that I've saved the file. I close the MATLAB, I start from scratch. So to do that, I'm going to do clear, I think, clear all. I should do it. This is a simulation. Here we go. So it looks now like I started everything from scratch. You can see that I started everything from scratch because in the workspace, there's nothing, right? What if I want to reproduce the work that I did last time? Well, thank goodness I saved it into my file, which is up there. That's my text editor. Remember, I told you that's inert. It's not doing anything. This is like it's as if it were written on a piece of paper and you're reading it. It's just sitting there. Nothing has happened. In order for stuff to happen, you have to run it. So one way to run it is to copy paste it. So I'm going to copy paste it, copy, and paste it to the command window. And now we see ans is 4. And x is 7, and I've recovered the work that I did the last time. Does that make sense? I can define another variable. I can do y equals x plus 3. Now I could make a mistake here. I'm not making a mistake now. I think I've done enough mistakes. And then it says y is equal to 10. When we do this, we should also reason, is this the right answer? Because if it's the wrong answer, well, obviously the computer didn't make a mistake. But if it's not the answer that we expected, then we made a mistake, and that line is actually correct, even though there's no error message. So, assuming that I've made a calculation on a piece of paper separate to figure out what is the right answer, and I got a 10, and now I have a 10, and I'm happy with it, and I copy paste this into my program, and I'm going to point out that the workspace now has x is 7, y is 10, and hence is still 4. Still all there. Okay? And now I'm going to do the thing that is slightly surprising. It's only surprising if you're a little bit too fixated on a certain aspect of mathematics, but if you expand your mind, then it's not so complicated. X I'm going to come back to my command window. I'm going to write a new piece of code. And I'm going to do x equals x plus 2. And I'm going to talk about this line of code. And then I'm going to wonder to myself, before I hit enter, you should always do this. You should always think, what is this going to do? What do I expect? Because after you hit enter, you get a result. You have to decide whether or not this is correct. So, okay, so let's think about this. So, if let's pretend for a second this is a mathematical statement that we are seeing. What is x here? It's a mathematical statement. Well, you can subtract x from both sides. So you basically cross them out, and you get 0 is equal to 2, right? Which is false. That's an incorrect statement. So this is what I mean when I say that there is a kind of a mental block with this x equals x plus 2. And it's a little bit the wrong way to think about what's happening. And so I'll quickly explain what's actually going to happen, and then I'm going to explain it a different way. So x is currently 7. 7 plus 2 is 9. So now there's going to be a new value of x, which is going to be 9. I'll do it now. So x is 9. X is 9, and we see up here. X is 9. So x was 7 before, and now it's 9. And so now we're led to think that perhaps 9 is equal to 7, which is another piece of confusion. This is all because we're thinking incorrectly about it. Here's a better way of thinking about it. When you do calculus problem, if I say integral whatever f of x, for example, and in the first problem f of x is x, and in the second problem f of x is cosine of x. Is anybody troubled by the fact that in one problem f of x is x, and in the other problem f of x is cosine of x? That's not a problem, right? We don't have to have f of x is x forevermore, for the rest of your life until your grave. It's going to be x. You're allowed to have a different f of x when you do different things, right? So what happens is that each time that you type a new command, it's like you're working on a new problem. Maybe a part B or part C. In part A, you had f of x was this. In part B, you have a different f of x. And in part C, you have another different f of x. Of course, sometimes you want to use the part A and the part B, so you still have the other stuff that was there before. And you're just evolving kind of in time, right? So the x variable is evolving over time. First it's 7, and now it's 9. It's a different x. Nobody's going to say that x is equal to cosine of x. That's not true. Those aren't the same functions. Nobody's going to say it's 7 equal to 9. It's just that every time you do one of these lines, it's a part A, part B, part C. Okay? And this is crucial to understanding programming. For loops. So very often with computers, we have very repetitive things that we want to do. So for example, I might want to do 1 plus 2 plus 3 plus 4 plus 5. That's repetitive, right? So of course, this is kind of a too easy example because I can easily write 1 plus 2 plus 3 plus 4 plus 5. But let's pretend that I was doing up to 5,000 so that it's hard to write. Okay? I'll do up to 5 and I'll be good enough. Okay? So let's do it the repetitive way, which is 1 plus 2 plus 3 plus 4 plus 5. Right? No problem. Now, what would be a way to do this up to 5,000 without killing ourselves? So we have to use the mathematical notation, maybe. We have to say that what we want to do is this. This is not a very good pen. Oh, yes. Then this is going to be my sum. This is what I want to do, right? So let's try to write a kind of repetitive program that is very, very much the same thing repeated again and again and again. to do this. So it's going to be highly repetitive. So I'm going to break the law now. I'm going to write it in the editor because I'm such an expert. If you're doing this by yourself, you wouldn't do it straight into the editor. But I'm such a big shot that. So I'm going to do k equals 1. So first of all, I'm going to put s equals 0. So s equals 0 because we're adding. So I'm going to do 0 plus 1 plus 2 plus 3. That's what I'm going to do. So I'm going to start with 0. Okay? And then there's a k here. So I'm going to do this k now. I'm going to do k equals 1. S equals s plus k. So this is a trick where we have to not get confused. We can't cancel the s's and say that 0 is equal to 1. That's not what's happening. There is a new s, kind of part A, part B, part C, that is created each time from the previous s to which we've added k. But in this case, k is 1, so it's going to add 1. Right? Now, I'm going to copy-paste these two lines 5 times. So 1, 2, 3, 4, 5. And I'm just going to increment what's called the counter. 2, 3, 4, 5. Can you guys see that I've really, really copy-pasted the exact same thing? Apart from the 1, 2, 3, 4, 5, it is verbatim the same thing. So it's repetition. Computers are amazing at repetition. You want to repeat something a billion times with a human? Impossible. Computer? No problem. Okay? And now, if I just ask for s at the end, I can do it with this, it's going to tell me the answer. So I should be getting 15, right? So I can hit the run button, which is somewhere, run, and it should do it. Uh-oh, it wants me to save it. Okay, I can save it. Thing.m. It's not a very good name. So now it says s equals 15, and the previous thing that I had done, it said 1 plus 2 plus 3 plus 4 plus 5 is 15, so it gave me the right answer. So now, I really didn't gate anything. It looks even worse than before, but now we see the repetitive nature of the task. And what I want to emphasize is that every other line, so there's the k lines, those are the counters. K1, K2, K3, K4, K5. That's just counting. The other stuff, the S stuff, that's what I call the body of the loop. Okay? So now, once you have this repetitive pattern, now you can do something. So I'm going to make another piece of code here. I'm going to do S equals 0 for K equals 1 to 5, S equals S plus K. So how did I come up with this? So the S equals S plus K, that's the body of the loop, and it's exactly the same as this. And the K, 1, 2, 3, 4, 5, that's this stuff. And this program that I wrote here is completely equivalent to this program that I wrote there, but it's a lot shorter. And now I can ask for S at the end, and if I run this, it's going to say 15. So let's do a CLC here. Okay. S is equal to 15, so it runs this. But now with this program, earlier I wanted to do up to 5,000. It was unreasonable. But now I can do it. So I can go to 5,000. I can run it. How much time do you think this is going to take? It's going to count to 5,000. It's a big number, right? I think, but actually, it's a good question. If there's a computer scientist, because we have math and computer science, the computer scientist should be able to take a guess how fast this is going to go. 0.01 second? Yeah, it's faster than that. Anybody else? About 1/1,000,000th of a second. It did it. You didn't see it, but it took 1/1,000,000th of a second. Okay, right? So that's amazing. So we can do this stuff with a computer. We can loop a billion times, and that's what we're going to do in this course. We're going to make these vibrating drums, and it's going to take a lot of loops. But the computer can do it.
Ajajabam Dumusmo.
Side note about history. Before we had computers, we didn't have computers. But we still had, I mean, we knew how to calculate this. We knew how to do this. We just didn't have computers. So how did we do it? It's very sexist. I apologize. It's very sexist. So this is World War I stuff. The word computer referred to people. So there were a bunch of people in a room, and there would be a head guy, von Neumann, or I don't know who it was, who would set out a task. We're going to calculate this rocket, or I don't know what they were calculating. I have no idea what they were calculating, but they were calculating big things, right? And they would hand out pieces of work to all the people in the room, and I'll let you guess the gender of the people in the room. And the reason is that, unfortunately, in those days, it wasn't allowed for if a woman was interested in science. That's the only thing that they could do. So, unfortunately, it's a piece of history that I'm telling you. I don't want you. Don't blame the messenger. I'm just telling you that. I don't agree with it. I'm just telling you what happened. So, and then we got computers, and so then fortunately now it's on my computer. So that's 4 loops. And I think truly the last notion that I want to show you about MATLAB, this is really a crash course because I'm showing you, in a sense, it looks very easy what I'm showing you, but it's actually, in a sense, kind of deep, and you might not realize now all the implications of what I'm saying about this. But the only way you're going to do that is if you actually try it yourself. So now I'm going to, I said earlier that you could have several workspaces, and I'm going to show you how that works to have several workspaces. So first I'm going to create a function. So a function looks like a script, but it also doesn't look like a script. So I'm going to go in new function. So this is a script. How do I know that it's a script? And this says scratch.m. This doesn't even say something.m. Well, okay, so scripts and functions are both stored in .m files, so that's not different. Well, the difference is that the first line of a function, it says function. And the first line of a script, it says, well, it can say whatever you want. Not function, but whatever else you want. Okay? So if it says function in the first line, it's a function. If not, then not. And what is the practical difference between a function and a script? A script doesn't get its own workspace. This script that I've got here uses the workspace that is right there. The workspace that you see right here. Remember I said a workspace is like a piece of paper, it's like your piece of scrap paper. Imagine this is a piece of scrap paper where all your calculations are. The function is going to get its own workspace. It's going to get a blank piece of paper with nothing in it. Okay? And that's a difference. That's the only difference between a script and a function. A function gets its own workspace, and a script works in the what I call the global workspace, the main workspace, the common workspace where everything else is. So each function has its own workspace. So now I will define the simplest possible function, which means I'm going to delete most of this. So I'm going to have one output, and I'm going to call my function myFun for no good reason, and one input argument, and the function is going to be y equals I don't know what function to take, cosine of x squared. Okay, so that's my function. There's one line inside it. It could be multiple lines inside. It's like a script. You can do the same thing as a script. Now, when I do, so I'm going to save it. When I do myFun of 3, it's going to do cosine of 9. I don't know what that is. Apparently that's cosine of 9. Okay? So it gives me the answer. Let's see it like this. MyFun of 3 is negative 0.9111. So that's cosine of 9. But we didn't see that it has its own workspace. But we can already see it a little bit because you see that in this global workspace, I have an x and I have a y, right? And the y is 10. But here in the function, it said y equals cosine of x squared. And apparently that's negative 0.9111. So y should be negative 0.9111. But it clearly isn't. It's 10. So what happens is there's two workspaces, one that we can see, which is the main workspace right there, and there's another one that we can't see. I'm thinking of that piece of paper that you do your calculations in the exam, and then you pocket it and left the room. I can't see that. My fund has a workspace that is pocketed when it left the room. You can't see it. And there's a y in there, and the y is this. So how can we see it there? Well, it's escaped that workspace in the form of n's. So now in this workspace, it's n's. Even though it's called y, in this workspace it's called n's. I can also give it another name. I can give it the name z. So I can say z equals my fun of 3. And now I'm going to have the z, which is over here. Oops, I didn't mean to do that. How do I don't even know how to close this. Oh, good. So now it's stored in z, not in y. There is another workspace where it was called y. It exists. We just didn't see it. Now I'll show you that workspace that's get thrown away. And to show you that, I have to use a fairly advanced tool of MATLAB that I encourage you to use if you can figure it out. It's called a debugger. So what I'm going to do is I'm going to click on this little symbol here, and it's going to become red. That's called a breakpoint. So now when I hit run, or when I do this, it's not going to do the whole program. It's going to stop on the red dot. So I'm going to change the parameter so that we have something different to look at. And then I hit enter. Now in the command window, unless I screwed it up, it should not print anything. It's going to stop. It's going to be very mystifying. So ready? I'm going to hit enter, and it's not going to do anything. Enter. Okay, so it did print something, but it didn't print negative 0. Or it didn't print a number. It printed 3 end, right? And now it says k greater greater. It's pretty weird. It looks different from before. That's the debugger. Okay? And now we can see here that I've got a green arrow, and that's telling us that it stopped the program there. Now we look here, and something very interesting is happening. The old workspace, it had Z and all this stuff in it. It's gone. And that is the private workspace of this function. And it has its own value of x and its own value of y. And it's not the same x as in the global workspace, and it's not the same y as in the global workspace. Okay? So now I've showed you the private workspace and the debugger. Okay? Now the debugger is very sophisticated. I'm not going to teach you everything about it. I'm going to click on continue, and then it should finish the whole function, and it's going to give me the answer, which is my fun of 4, which is going to be something that's not, well, it's negative 0.9577, it says right there. Here it's in y, but that's in this workspace. What's it going to be called in the other workspace? It's going to be called z, because that's what I asked for here. So it's going to get stored in the z. So now I'm going to do continue. And now it says z equals negative 0.9577. My global workspace has been restored, and the z value is now here. Okay? So there's another thing called an if condition. I showed you the for loop. I'm not going to show you the if condition. You can look it up yourself. But now, I think if you really absorb the information that I gave you, like really deep into your brain, think about when you're riding your bike, like a little kid. My kid's 4, right? So, you know, he's scared and he can't stay up, and it's very. And then a couple of years, he's going to be jumping and doing tricks and wheelies and stuff like this. Right. So if this is new to you, then you know you're scared and you can't stay up and stuff. But you have basically the whole, like my kid has everything he needs to ride the bike. But you need to practice to get to the point where you do the wheelies, right? So it's practice from there. It's your brain is going to evolve as you do this. I mean, you have to really get all this stuff sort of going. It's a lot of practice. I promise it's a lot of practice. It's a lot of practice.